Hi, this is a short video to go over some of the problems that are on the review sheets for your exam tomorrow. This is an example. This one is from page 71 in your packet. It's a square prism. The base is a square. One of the things that's kind of weird is the way that this is labeled. The picture's not that great. The 13 that is over there on the side, they're meaning it to be one of the outer edges like this. So we've got to do a little bit of math here to figure out what the different elements are of those dashed lines that we have. So I'm going to draw one of the faces of the triangle. This side over here is 13, one of the edges. We know that the base is 10, and we want to figure out what the height of that triangle. We'll use that for the surface area. I can split this triangle into two pieces here, right? And so this would be 5, this would be 13, and so it looks like the slant height is going to be 12. Remember, the slant height is going from the base of the shape along one of the faces up to the apex. All right. So we can use that to find the surface area. So for this shape, the surface area is going to be the area of the base shape plus 4 triangles, which are the sides, right? Oops. The base in this case is 10 by 10, right? So it's a square. And then the triangles are going to be 1/2, the base is 10, and the height is 12. So it looks like I've got 100 plus, let's see, I'm getting 240 for this. So it looks like the surface area for this shape is 340 units square, right? Okay. Now we'll tackle the volume next. The formula for volume is 1/3 the area of the base times the height. And in this case, the height that they're talking about is on the interior of the shape. It's going to be in here, right, going to the center. So if I draw that triangle that's on the inside, I know that this length is 5. We found this side, the slant height, to be 12. And so that means that if I use the Pythagorean theorem, the height of this is 13. So the height of the pyramid is 13. All right. So the volume then is going to be 1/3. The base we found was 100, and the height is 13, or 1300 over 3. If you simplify that, you get, let me just double check, 1300. Yeah, you get 433 1/3. And this is units cubed. This is the volume. All right, let's look at another shape. This one's a little difficult. The way that I think about this is that it's, let's see, how many sides does that have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. It's got 7 sides. So it's a prism with a 7-sided base, right? As far as figuring out the volume, what I'm going to do is think about it as if it were just a rectangular prism with the base like this, but then remove this little trough piece that's in the middle. So actually, let me draw this a little bit bigger. is not to scale, but we know that this length is 3, this length is 3. And so then that means that this distance here has also got to be 3. We know that this is 3 and this is 3. So this little trough that's in the middle is an equilateral triangle. This is 8. This side is 9. This side is 8. I'm trying to figure out the area of this base shape so I can use it to find the volume. For volume, we want to use the area of whatever the base shape is multiplied by the height. The height in this case is going this way, right? The height is going to be 8 in this particular case. So if I were to think about this as maybe a rectangle, and I'm removing this little triangular piece, I need to figure out what the height of this triangle, oops, let me undo that, hang on. Oh, hold the phone for just a second. There we go. I need to figure out the height of this triangle, which is here, so that I can remove that piece of it. So if we look at this triangle here, this side is 3, this side is 3. And we know from our experience with the Pythagorean theorem and also from special triangles that the height of this is going to be 1.5 times the square root of 3. Okay, so I think that the area of the base is going to be 8 by 9. That would be if I just multiplied and I had a rectangle. And then minus 1/2 the base, which is 3, times the height, which is 1.5 times the square root of 3. All right. So 3 times 1.5 divided by 2. So I'm getting 72 minus 2.25 times the square root of 3 for the base. Then, to find the volume, it's going to be the base multiplied by the height, which we said was 8. 72 times 8 is 576. And then 8 times 2.25 is 18 times the square root of 3. So this is the volume. All right, let's tackle the surface area next. Let me move this down. For the surface area, we have 2 bases, and then we'll take the perimeter of the base shape and multiply it by the height. What's going to happen is it's going to take all of the sides and it's going to add them all together. When we take the perimeter going around the shape here and multiply it by the height, it'll get all of the sides together, right? So the perimeter of this, we kind of have that in this drawing here in the red. I think that the perimeter is 8 plus 9 plus 8. And we have 3 multiplied by 4 there, right? So I'm getting 16 plus 37. Let me just double check that. Yeah, I'm getting 37. So the surface area is going to be, oops, 2 times the base. I'm taking the base that we found up above, 72 minus 2.25 times the square root of 3. Plus, we've just found the perimeter was 37 and the height of the shape is 8. So that is 144 minus 4.5 times the square root of 3 plus 296. So I'm getting that the surface area is equal to 440 minus 4.5 times the square root of 3. And this is units squared, right? I forgot to write the units up here. This is units cubed, right? Okay, let's do one more example. This is something that we did quite a while ago. I just kind of wanted to remind you guys about it. We used Pick's formula to solve these problems. Pick's formula was looking at the number of interior points plus the boundary points divided by 2 minus 1, and that gave us the area. Sorry, I had to pause for a second because my computer was about to die. All right, so I'm going to count up the number of points that are on the interior here, and it looks like I've got 1, 2, 3, 4, 5, 6. So I've got 6 on the interior, and then I'll count the number of boundary points, 1, 2, 3, 4. So I've got plus 4 over 2 minus 1. So it looks like the area here is going to end up being 7 square units. Another way that we can think about solving this problem is to take the area of the entire grid. The area of this whole grid is 4 by 4. So it's 16. And then I've got 3 triangles that I can think about removing. I've got a triangle here. One of the sides is 2 and the other side is 4. So the area of that triangle is going to be 4. So we will subtract off 4 for one of the triangles. And then this triangle over here is 2 by 3. So I'll subtract off 3 for that triangle. And then this triangle over here is 1 by 4. So we'll subtract off 2 for that. So the other way to think about this area of the inner triangle is 16, that large square, and then subtracting 9 from all those red triangles on the outside, and that gives us that same answer, same answer of 7. All right. If you have other problems that you'd like me to do, send me an email and I can make a short video for you. Have a great day.